Here's your passage properly punctuated for clarity and flow. Have you ever thought about whether we're truly alone in the universe, or if there's more to our existence than what we see? What if the James Webb Telescope finally proves that we live inside a black hole? Join us as we learn more about this groundbreaking news that will make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you might have seen them in sci-fi movies, but the reality is even scarier. According to scientists, they're not just pitch black holes in space. They're actually massive amounts of matter squeezed into an incredibly small area. Think of a star 10 times more massive than the sun, all packed into a sphere the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for centuries, ever since they pondered objects in space so massive and dense that they could trap light. The most famous ideas about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a tiny, dense core. If this core's mass is more than 3 times that of the sun, gravity overwhelms everything else, leading to the formation of a black hole. Detecting black holes is no easy task since they don't emit any light. However, scientists have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will pull that matter toward it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can get torn apart, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, emit powerful gamma-ray bursts, and even influence the growth of new stars in some areas while stalling in others. But where do black holes come from? Picture this. Stars, once magnificent and blazing, meet their ultimate demise in a spectacular explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached their celestial retirement party in a supernova blast. Smaller stars, when they die, transform into something called neutron stars, which are super dense but not dense enough to trap light. However, if a star is about 3 times the mass of our sun, it collapses under its own gravitational pull, forming a black hole. As these mighty stars collapse, something strange occurs near their surfaces. Time itself starts to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the point of no return for anything falling into a black hole. It's like the star's clock ticks at a different pace compared to ours. Sometimes, when 2 smaller black holes collide, they combine to form an even bigger and scarier black hole. If a black hole teams up with a neutron star, they create a colossal nightmare that defies comprehension. Scientists have been grappling with the scale of these cosmic phenomena for years. Black holes come in 2 sizes, huge and small. There's a sinister mystery surrounding them that we can't seem to unravel. But here's the twist. Small is relative when it comes to black holes. Stellar mass black holes, remnants of massive stars, can be as large as 10 to 24 times the size of the sun. There could be as many as 10 million to a billion of them in the Milky Way alone. That's an astronomical number of black holes that could swallow anything in their path. But wait, there's more. Supermassive black holes are on the other end of the spectrum. They're millions, if not billions, of times larger than the sun. They exist at the center of large galaxies, including our very own Milky Way. It's like a gaping dark void pulling everything toward it. Renowned physicist Stephen Hawking talked about black holes throughout his lifetime. His lectures were always insightful, but some of his theories couldn't be confirmed due to a lack of necessary equipment. However, there's hope on the horizon. A single scientific instrument is changing everything, and we're not ready for it. It goes by the name of the James Webb Space Telescope, also known as JWST, and it's here to plunge into the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to the potential of human ambition. Sure, we've launched other space telescopes before, and they've been doing their jobs just fine, but this bad boy is in a class of its own. The JWST makes the Hubble telescope, which has dutifully served us for years, look like a mere speck in the cosmos. And the price tag of this astronomical wonder? A whopping billion. Yes, you heard that right. That's enough zeros to make your head spin. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, not to mention the invaluable input from over 300 universities. But let's not forget the risks that come with such a grand undertaking. The JWST is venturing into uncharted territory, pushing the boundaries of what we know and taking us to places we've only dreamed of. Since its launch, the JWST has made many incredible achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside permanently. During its journey, the telescope successfully unfolded its massive 5-layer sun shield and giant main mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has fine-tuned and calibrated it, the telescope is almost ready to go into full operation. One of the most exciting moments was when NASA announced that it had captured its first images of starlight. Thanks to its sophisticated technology, the JWST will help scientists investigate the early stages of the universe after the Big Bang. It will study what happened after the first stars formed, a period known as the Epoch of Reionization. This era refers to when neutral hydrogen was reionized, or made to have an electric charge again, by radiation from these first stars. The JWST will also help scientists discover exoplanets, which are very difficult to spot because of their interaction with their host stars. Its powerful sensors will allow it to observe these planets in more depth, including, in some cases, imaging their atmospheres. Understanding the atmospheres and formation conditions of planets could help scientists predict whether certain planets are habitable or not. Apart from studying galaxies, black holes, and exoplanets, the James Webb Space Telescope is also searching for answers to some of the most profound questions. Are we alone in the universe? Are we living inside a black hole? With each new revelation, we inch closer to unlocking the dark and startling secrets of the cosmos. The interplay between black holes and the structure of the universe remains a tantalizing mystery. Each new discovery brings us closer to understanding the fundamental nature of reality, revealing a cosmos far more intricate and interconnected than we ever imagined.